So I gladly accept your um, in time. So this program is basically for mechanical industrial engineering. So a topic which I have tried to is application of soft scheduling. Sometimes soft computing techniques in various areas. So coming to the next slide, next slide. नेक्स्ट स्लाइड कहीं होंगे हाँ पूरा अच्छा ठीक so these are the today's afternoon discussion introduction basically focusing on scheduling problem solving techniques flowchart soft computing and application area of soft computing and you can say where it will be applicable actuarial science like prediction of bonds, that is banking or insurance like that. Agriculture engineering, biomedical applications can be applied it, or you can say computer engineering, or you can say industrial machineries, or particularly mechanical engineering. You can say crime forecasting, data mining, or environmental engineering, or you can say fault tolerance, feature selection, image processing, pattern recognition, polymer extrusion process, or you can say process control, signal processing, or you can say smart instrumentations. And in short, we'll have a description of soft computing in different areas and references and conclusion. So before, because since it is a mechanical faculty development program, it will be not justified, or I will be giving injustice if I do not focus on my specialized or our specialized areas. So before focusing on that scheduling concept, because each participant must have some basic knowledge of, you can say, about production and operation management. Why is production and operation management important in both manufacturing and service firms? Because you will find production, the creation of products and services, is an essential function in every firm. Production turns inputs such as natural resources, you can say raw materials or human resources, or you can say capital, and you can say input into outputs, which are nothing but in terms of products and services. This process of managing this conversion process is the role of operation management. So you will say, because I am not, these are slides. Is it visible? Is it visible? Is this slide visible?
Yes, sir. Yes.
Okay. So this is what production is. And you will find basically production and operation management involves three main types of decisions, typically made of production planning. The first decision facing operation manager comes at the planning stage. At this stage, managers decide where, when, and how production occurs. They determine site selection, or you can say plant location, you can say site locations, and obtain the necessary resources about their availability, whether it is in comfort zone or not, that has to be taken care of. And in the second stage, you can say production control. At this case, the decision-making process focuses on controlling quality and cost. And important is The talk of the day is scheduling. We'll focus on that, scheduling. And the actual day-to-day operations of running a factory, or you can say otherwise service facility. You'll find improving production and operations. The final stage of operation management, which focus on producing the farm's goods or services. So basically, focusing on that, you will find what is a production system. The production system of an organization is that part which produces the products of an organization. Or you can say, in other words, system is a collection of interrelated entities. It is, you can say, it can be complex also. So production function is that part of an organization which is concerned with the transformation of range of inputs into the required output. Outputs can be in terms of products or services, whatever it may be, having the requisite quality level. And you'll find manufacturing organization that are primarily produce a tangible products. Tangible means countable or measurable, which can be count or which can be measured. Tangible products, and typically have low customer contacts. We do not get contact directly. Okay. So another organization can just focusing on service organization that primarily produce an intangible, not countable. Okay. So intangible products are not measurable, such as ideas or assistance or informations. That factor is to be taken into. So coming into the next stage, before about some typical production or productive system, let us take a case study of different, for example, I will say hospital. In a hospital, you will find inputs are patients. What conversion process they are undergoing health. What are the outputs? Outputs are cured patients. And similarly, you will find auto factory. What are the inputs? Raw materials. In conversion process, what you are finding, you are undergoing or taking fabrication and assembly of autos. And what are the outputs? Outputs are finished good, or you can say finished automobiles or final shaped automobiles as per desirability. Similarly, we can take case of oil refinery. Crude oils is the input. Conversion process, that is your chemical processes. Outputs can be gasoline or oil or plastic, whatever it may be, etc., etc. If you take the case of airlines, where the scheduling concept is very useful, where the scheduling case is, that is allocations, resource allocations. So you will find in airlines, what are the inputs? Airplanes, pilots, flight attendants, suppliers, customers, etc. What are the objectives or the conversion during the conversion process? That is air transportation. It is the conversion process, that is means transporting from one destination, one place to other place. Okay. So transporting to the destinations, and output, what is the output? Customer transported to destinations. And finally, you will find last option is social security can be considered as a production system. Inputs, who are eligible individuals for taking, for example, if you want to take a purchase a bond or health insurance. So some eligibility criteria, certain age, up to certain age, you are eligible. That criteria is fixed by the organization, social security. So conversion process system for validating eligibility and processing benefits, that will undergo the process and output a measure of economic security for retired persons. So this is, and if you look into this sketch, this is in a broad scale about a system, because these are the preliminary requisites required in any scheduling or any manufacturing or any mechanical or any system required. This is the basic idea moving into the next. So you'll find what are the inputs. Let us take, this is how the system is. Let us take a case study which has been observed, or a paper, that is fast food outlet as a production system. So inputs, you'll find what are the inputs. You can say ground meat, buns, or your potatoes, or your some condiments, or soft drinks, whatever it may be. These are the inputs. So they are undergoing transformation, or you call so-called, we call conversion process from hamburger patties, fried, cut into French fries, etc. Take orders, assemble orders, serve. And you will find the bundle of products and services is coming out. Now the thing is, if this is the system, these products are taken by the customers, and if they are not satisfied with the quality of the food, they give a launch a complaint that this is not a good quality product. This is not a good quality product. That means these customers give a feedback that we want more quality product. So information feedback system is there for process control. And these three things, that is your input, conversion process, and output, I can rename or reterm it as efficiency, system effectiveness, or productivity of system. So how do we define efficiency? Proper use of inputs. Proper use of inputs. That is, we define, or we call the efficiency. Proper use of inputs. Similarly, proper use of system. System effectiveness. System effectiveness. And similarly, you will find how well inputs get converted into outputs. Productivity of system. How well inputs get converted into output. We call the term called productivity of system. So we are not going to detail elaboration rather. And in a nutshell, what I have discussed, we have discussed, this is the model of entire things of highlight, because time stipulated to me or assigned to me is 1.5 hours. So with that, I have to give in a nutshell the entire things, whatever will be, or whichever will be useful for any faculty to understand, isn't it? Covering the mechanical engineering areas. So in any general model, you'll find three important parameters are required, three important stages. One is your planning stage, another is your organizing stage, another is your controlling stage. So in planning stage, you'll find operation strategies. You'll go get there. Forecasting already known. Product and process choices depends. Operation capacities, similarly facility location planning, layout planning, and important of the talk of the today's afternoon session is scheduling conversion system. Scheduling system, aggregate planning, operation scheduling, etc. And in organizing section, you'll find for conversion, that is your job design, production, operation, standards, work measurement, your time study. That is basically focus on industrial engineering. I have tried to focus because being organized in such a manner that everybody can, that this subject will be acceptable to all. So work measurement, that is time study, job evaluation, merit rating, all those terms will be coming into. That means as an industrial engineer, as a manager, he should be well acquainted. Okay. So you'll find project management is also there. And in controlling stage, what one should be aware about, material control, we call it inventory control. Material requirement planning, managing for world-class competition, that is GT, just in time, or push system or pull system, that, or you can say Japanese manufacturing, managing for quality. Because every day we always talk of quality. Always talk of quality. Quality is nothing but the degree of conformance specification. Degree of conformance to specification. Or in other words, I can say any product which is fit for use is a quality product. Any product which is fit for use is a quality product, obviously. And obviously, you can say if the customers are delighted, if the customers are happy, if they are happy that this is useful, the product which they are using, it is useful, then you can say that is a quality product. So quality analysis and control, all these things are preliminaries for any mechanical. So now focusing on the real title of the topic, coming to the topic of the computational science. That is, in computational science, computation, mathematically, we are calculating. So in computational science, scheduling is a method by which work specified by some means is assigned to resources that complete the work. I repeat, in computational science, scheduling is the method by which work specified by some means is assigned to resources that complete the work. So what are the principles to be taken care of? You can say principles of scheduling. Principles of scheduling. Number one, or the important principle is principle of optimum task size. The principle of optimum task size. So what is this? The scheduling tends to achieve maximum efficiency. Maximum, when it will achieve maximum efficiency? When the task size are small. When the task size are small. And all tasks of same order of magnitude. And all tasks of same order of magnitude. We'll look into the problem on this. Then second is principle of optimum production plan. The planning should be such that it imposes an equal load on all plants. That means the planning should be such that it imposes an equal load on all plants. That means one should not be overburdened and another should not be less burdened. So it should be equal so that nobody will complain. Nobody will complain. Or nobody is overburdened, isn't it? So that something will happen. So principle of optimum production plan is a criteria to be taken into consideration. Then important term is principle of optimum sequence. Principle of optimum sequence. You will find scheduling tends to achieve the maximum efficiency when the work is planned so that work hours are normally used in the same sequence. In the same sequence. So looking into the problem, coming into the problem case, before proceeding to the problems, these are some of the terminology or terms associated in any scheduling problem. Because for example, if I say that a cricket match, for example, if a student is asked what are the terms or terminology associated in a cricket match, he can say a bat, he can say a ball or a LBW, wicket, hit wicket, caught behind. So many terms are applicable. Wide, all those terms. Similarly, in that similar context, you'll find the parameters of a scheduling problem are make span. Technically, the term is make span. So how do we say make span, flow time, lateness, and earliness? These are some of the important terms or terminology in case of scheduling problem. So you'll find Graham stated that the most commonly used criteria for scheduling problem is the minimization of make span. Which is what is make span? Make span is the time required by the large in the sequence to be processed in the last machine. I repeat, make span is the time required by the last job in the sequence to be processed in the last machine. Time taken to complete the last job in the sequence, that is. Another parameter is your flow time. The second most widely used criteria are the flow time minimization. Flow time minimization. It refers to the time the job was present in the shop. Second most widely used criteria are the flow time minimization. It refers to the time the job was present in the shop. It is defined by the interval between end and starting time of job processing respectively. This reduces the work in inventory. Each job would have a different flow time. Another important parameter to be recalled is that lateness. Because remember that if you are early, it does not have any weightage. If you are late, then definitely there will be penalty. Suppose you have been given a time to reach by 8 a.m., you will find at 8 a.m. you should reach. If you come at 5 p.m., 5 a.m. instead of 8, that means it is a loss to the organization. So earliness, that is sometimes also penalty. Lateness is also penalty. Earliness, coming early, has no usefulness. But you must be in time. 8 a.m. is 8 a.m. So lateness, another important criteria for minimizing or minimization is lateness. That is the time period by which the job is late from the actual due date. Generally, some penalties associated with the lateness of the job. Earliness, another interesting parameter for minimization is the earliness. It is the amount of time job is finished processing ahead of schedule. Similar to lateness, some penalties also associated with the earliness, as the finished job needs to be stored as inventory. So these are some of the parameters. So before that, these important key terms to be coined are sequencing and scheduling. Sequencing and scheduling. So you will find what is sequencing. Please remember, because since we are focusing on mechanical oriented topic, having computer based a hybrid topic. So because basically we'll be focusing on our mechanical portions. So sequencing, it is the selection of an appropriate order for a series of jobs to be performed on a finite number of service facilities. So sequencing plus time is scheduling. So what is scheduling? Scheduling is nothing but allocation of resources over time to perform a collection of tasks. Allocation of resources over time to perform a collection of tasks. So before going for this, you have to follow certain rules, regulations. So we call this in scheduling culture or scheduling literature, we term this scheduling priority rules. Priority rules for dispatching, or some people or some authors or some writers, they call it as priority dispatching rule. So priority rules for dispatching. So many rules are there, but I have taken only this 4. First is fast come fast serve. पहले आओ पहले निकलो. Fast come fast serve. FCFS. Fast come fast serve. Then second is shortest processing time. The person at the process which take less time will be given priority. Shortest processing time. मान लो हमारा क्लास में, मान लो एग्जाम्पल है, हमारा क्लास में क्या करते हैं, स्टूडेंट 60 स्टूडेंट्स रफली आई एम टेकिंग, 60 स्टूडेंट्स आते हैं क्लास को, 60 में से किसी किसी का प्रॉब्लम होता है, 60 स्टूडेंट्स में किसी किसी का प्रॉब्लम होता है, जिसका प्रॉब्लम होता है वो क्या करते हैं, व्हाट ही डज, ही अप्रोच द टीचर, वो पूछता है सर कल क्लास होगा क्या, whether tomorrow there will be class or not, yes, टीचर बोलता है yes और टीचर बोलता है नो, नहीं होगा, either yes or no, so it consumes a fraction of second to reply. So another student सर पूछता है सर आपने शेड्यूलिंग का बारे में बोला, what is that term, priority dispatching rule, can we debate that rule and do some order, he asked. Sir, you have only given 4 options, priority dispatching rules. आपने बोला फास्ट कम फास्ट सब और कुछ 4 रूल बताया, you have told only 4. So can I do some other rules? No, you wait. So this question will take some 2 to 3 times or 2 to 3 minutes to explain him. Well, wait. I told him wait. Then another student asked, sir, you have solved that model, general model. Can you tell me how it is GT is coming into picture? You have written somewhere GT, that Japanese techniques you have written. How it is applicable? Well, what? Then another problem another student will bring, has a doubt of mathematics. How you have derived it? Can you derive that? You'll ask. Well, what? So depending upon the, I have evaluated all students. That means who is taking how much time. As a teacher, I am just evaluating from my memory, that from my knowledge, from my experience, that how much this student is taking. So one student is asking, sir, tomorrow class will? Yes. So he can be given. He will not be asked to wait. You go, tomorrow will be class. Then another problem, sir, you have told this problem that only 4 rules. Can I do up my more? Yes, you can do. So that is called random. So you can randomly, you can pick any random, by random order. Random order you can take. Yes, you can try. You can try. So I gave him, so it is 2 minutes I can. So another student is coming into last, is coming that this problem, numerical problem is there, sir, I couldn't understand this model. You just tell me. So you just wait. So he has to wait for 10 minutes. Then I have to solve his problem. For another 30 minutes, I will sit with him 20 minutes. Because he is interested and I am also not preoccupied. So I will definitely try to manage his problem or solve his problem. So thereby we call it the shortest. So any system having shortest process, not necessarily, it depends upon the team who is working on this. So you can choose this and accordingly you can apply the subcomputing techniques or whatever it may be, which we will be discussing or elaborating. So shortest processing time. Then another is your earliest due date. Another is your longest processing time, LPT, longest processing time. So applications of scheduling, coming into applications of scheduling, parts waiting for processing in a manufacturing plant, parts waiting for processing in a manufacturing plant, aircraft waiting for landing clearance at an airport. That means at which site it will come, that will be until and unless it is clear. So you aircraft waiting for landing, clearance cannot be given. Similarly, computer programs running at a computer center, patients waiting in doctor office. So that is a queue. That is your queue. So these are the some of the importance. So now coming how the scheduling problems will be applicable. How the scheduling problems will be applicable. Let us take a case study for because Johnson algorithm is there. So in scheduling, you'll find Johnson algorithm is there. What is this? You'll find, let us take a simple case from this problem that there are 6 jobs. There are 6 jobs to be done on 2 different machines. I can call these machines as AM1 and AM2 respectively. So machine number AM1, machine number AM2. You look into that table, it is 1 and 2. So suppose I'll say job number 1. I can say call it a job J1. Here I have written J1 simply. So usually notation is J1. So J1 you will find if it is taking, that is machine 1 is taking 5. You can take 5 minutes or 5 seconds or 5. It should be uniform. All the table on machines, it should be uniform. And if it is in 5 hours, so all the table data should be in hours. If the table that is 5 minutes, all the information should be uniform. That means I mean to say all should be in 1 unit. So let us take it is 5 minutes. Let us take 5 minutes. So machine 1, job 1 is taking 5 minutes on machine 1. Similarly, job 1 is taking 4 minutes on machine 2. You'll find job 2 is taking 2 minutes. Job 2 is taking 3 minutes on machine 2. Job 3 is taking 13 minutes. Job 3 is taking 13 minutes. Job 3 is taking 13 minutes. Job 3 is taking 14 minutes in machine 2. Job 4 is taking 10 minutes on machine 1. Job 4 is taking 1 minutes on machine 2. Job 5 is taking 8 minutes on machine 1. Job 5 is taking 9 minutes on machine 2. Job 6 is taking 12 minutes on machine 1 and 11 minutes on machine 2. So what the law says, or what the principle says, or what the rule says, or what the algorithm says. Johnson in the year 1959, what he elaborated, he found out logically that find the minimum among various T1, I1, TI2. TI1, TI2. That is, from the table M1 and M2, you'll find all those times 5, 4, 2, 3, 13, 14, 10, 11, 1, 8, 9, 12, 11. So, which is the minimum time? So, it is saying that if the minimum processing time requires machine 1, place the associated job in the first available position in sequence. Go to step 3. If the minimum processing time requires machine 2, place the associated job in the last available position in the sequence. Go to step 3. Step 3 क्या बोल रहा है? Remove the associated or remove the assigned job from consideration and return to step 1 until all positions in sequence are filled. Time may be broken randomly. Okay, it is not necessary. Suppose I'll just come to that problem. Let us take the case study of 2 machines and 6 job scheduling problem. Here in this problem, you will find which is the machine smallest time. Smallest time is on job 4, machine 2, that is 1. Job 4. Please look into the table. Job 4, 4 number serial, job 4. On machine 2, that is 1. Time is 1. So it is the smallest among the table. So this job will be kept at the end. So you will find the optimal sequence is 4. Last serial is 4. So job 4, machine, that is 2, that will be 8. So remove that row. So job 4 is removed. After removing, which is the less time taken? So job 2, that is your job 2, that is your machine 1. So keep it in the fast. So that's why you'll find optimal sequence is 2. Fast is 2, last is 4. So remove that job 2 row. Which is the less time? Now it is job 1. Because 4 is the time taken in machine 2, that is it should be kept at the end. So remove that row. So after besides 4 in the side, left side of 4, you'll find 1 is there. So job 1. Then similarly, remove that row, that is job number 2 is removed, job number 1 is removed, job number 4 is removed. So job 2, 1 and 4 is removed. So only left is 3 and 6, 5. So from that, you'll find job 5 is there. So job 5, 8 is the least minimum time. So besides 2, job number 2, job 5 is kept. And finally, you'll find job 6 is placed in the middle. Okay, that is your job. 13 is there. Job 3 is there in the besides 5. Job number 5, 3 will be there, and similarly, job 6 is the last portion. Job 6, that is 12, 11, and 13, 14. So job 4, job 3 will be at the end. Job 3 will be at the end. That is your in the middle. In the middle, it will be there. So the optimal sequence is 2, 5, 3, 6, 1, 4. Maximum for the schedule is calculated. So by taking this sequencing order, you can calculate the in time and out time, and thereby you can get a calculation table to be 53. So moving ahead to the topic, how it is applicable. You'll find scheduling, that is how it is scheduling is applicable. So scheduling is applicable. Scheduling is applicable. You'll find algorithms, heuristics, and meta heuristics. Heuristics and meta heuristics. Scheduling algorithms can be classified into 2 categories, or you can say we call it 3 categories usually. So one is your exact algorithm, exact. Another is your heuristics, another is your meta heuristics. So scheduling algorithm, exact algorithm, heuristics, meta heuristics. Exact algorithm, you will find optimal solution. Optimal solution you will get through exact. So exact solution can be, for example, 2 plus 2 is equal to 4. That is exact solution. Exact. Very. If someone says 2 plus 2 is equal to 3.99, that is near optimal solution. It is an approximate solution. So solving such kind of problem is through heuristics or meta-heuristics. So, in short, you'll find exact algorithm, integer programming, branch and bound methods. For NP, non-deterministic polynomial, NP hard, scheduling problems, heuristics and meta-heuristics are preferred because they are, as the problem size increases. If in the class, if you ask a student, what is 2 to the power 3? 2 to the power 3, he will definitely say it is 8 or 16. 2 to the power 3, he will say it will be 2 into 2 into 2, so it will be 8. Isn't it? So 2 to the power 3, 2 into 2 into 2, that is 4 into 2 is 8. If you ask the same student, what is 2 to the power 1 lakh? If you ask the same student in the class, can you say, he will suddenly say, so when you ask 2 to the power 1000, so he will take time, he will kill time. So that means solving such kind of problem is a difficult and cumbersome task. It will take time. But as a industrial engineer, as a mechanical engineer, we have been assigned with the task to complete the task in scheduled time, isn't it? So we want to finish the task as per the needs, as per the requirements of the management, as per the organizations, we have to complete the task as per the needs and requirements, isn't it? So how quickly the solution you will get, you have to find a logic, you have to find a solution for that. So that is your heuristic. Heuristics or meta-heuristic, that heuristic, it is nothing but a rule of thumb. Rule of thumb. You can say, someone may call it a tantra or something like that, whatever it may be. But it is a rule of thumb. There is no guarantee. There is no guarantee that your solution is exact, isn't it? So 2 plus 2 is equal to 4. That is fine. Exact solution. That is optimal solution. And 2 plus 2 is equal to 3.9. That is your near optimal solution, not exact. So heuristics is nothing but problem specific information. Problem specific information, and hence are less general. Heuristics are nothing but problem specific information and hence are less general. They frequently produce good near optimal solutions in reasonable computation time, because if you go on calculating, it will take years. It will take years. But we want the solution in certain time, because management has given entrusted the tasks to complete in time. And remember, there is what saying, a stitch in time saves nine. So you must be in time, isn't it? You want to get a solution. We are management not saying exact. If it is exact, it will take years. But we want in a certain duration of time, we want to solve it. Now, next is meta-heuristic. Meta-heuristics. Meta-heuristics are robust, you can say adaptive, search, optimization for difficult and complex problems requiring much larger computational times compared with heuristics. So meta-heuristic, you will find problems requiring much larger computational time compared with the heuristic. So this is the lacuna in use of, I think this Johnson. So this problem is there. Now coming into the concept of the talk, that is soft computing. How and where it is used. Soft computing, you'll find, refers to the science of reasoning Soft computing refers to the science of reasoning, thinking, and deduction that recognizes and uses real-world phenomena such as grouping, memberships, and classification of various quantities under study. Various quantities under study. It extends natural heuristics. It extends natural heuristics and is capable of dealing with complex system. It extends with natural heuristics and is capable of dealing with complex systems because it does not require strict mathematical definitions and distinctions for the system components. Unlike hard computing, you'll find soft computing is tolerant of imprecision. That means hard computing is precision. Soft computing is tolerant of imprecision. Uncertainty, there is no guarantee. There is no guarantee that your solution is correct. There is no guarantee. You cannot say, you can say correct, but it is not exact. The solution may not be exact. That is the thing. So you can say strict mathematical definitions, it extends natural heuristic and is capable of dealing with complex system because it does not require strict mathematical definitions, distinctions for the system component. So unlike hard computing, soft computing is tolerant of imprecision, uncertainty, there is no guarantee, and partial truth. Partial truth, we call the term partial truth. So you can say essentially the role model for soft computing is the human mind. Role model is for soft computing is the human mind because human mind is very important. So the guiding principle of soft computing is to exploit tolerance for imprecision, uncertainty, and partial truth to achieve tractability, that is tractability, robustness, and low solution costs. The main techniques in soft computing includes evolutionary computing, artificial neural network, fuzzy logic, Bayesian statistics, especially used in mathematics. While each technique can be used separately, the complementary nature of these techniques, when used together, can produce solutions to problems that are too complex or inherently noisy to tackle with conventional mathematical methods. So here is at a glance, this is how to solve problem-solving techniques flow charts. So problem-solving techniques can be hard computing. It can be soft computing. You'll find hard computing is precise model. Please note, it is precise model. Look into the chart, it is precise model. Whereas soft computing is approximate model. Approximate model. So precise model can be symbolically, or you can say symbolic logic reasoning. You can say traditional numerical modeling and such. That is precise. Okay. And in case of approximate model, you can say approximate reasoning, and functional approximation, and randomized search. So you can say approximate modeling or approximate reasoning can be basically probabilistic model. Another is your fuzzy logic. Well, these terms are basically core branch of computer science. Okay, still people, because we the people from interdisciplinary use those. And it has been, all other branches also are using quite often or very often. Probabilistic model, you find Bayesian belief needs, that is another theory. Probability of fuzzy events, all those terms are there. Belief of fuzzy events, and you'll find fuzzy logic. Fuzzy logic controller generated and tuned by, then fuzzy logic controller tuned by neural network. Then you can say that is your functional approximation and randomized search, randomized random search. So you'll find that this evolutionary computing and neural network is again feed forward neural network and recurrent neural network. Feed forward, or you can say evolutionary computing is, you'll find evolution strategy, evolutionary programming, GA, genetic programming, all those terms are there in basically in computer science, technology, or engineering if you go. So how these applications, looking into the application part, the application of soft computing have demonstrated two main advantages. What are they? You will find first, you will find solving any non-linear, not linear, not straight. Okay, parabola, all those things. Solving non-linear equation or problem. Any problem which is non-linear. That means, for example, soft computing has made it possible to solve non-linear problems where mathematical models are not easily available or not practicable. And second is incorporating human knowledge. It has introduced human-like knowledge. Such as cognition, recognition, understanding, learning, and others into the field of computing, leading to the construction of intelligent systems such as autonomous, self-tuning system, and automated design systems. And you'll find in this work or in this paper which we are sending it, trying to send, not published. So you'll find this soft computing is a partnership, not a mixture. Soft computing is a partnership. Okay, soft computing is a partnership, not a mixture, where each methodology uniquely address domain-specific problems. Right? So you will find what are them. First is complementary methodology. The principle, or you can say principal methodology in soft computing are complementary, not competitive. Second is intrinsic capacity, or you can say intrinsic capability. What that? You'll find soft computing methods or soft computing main characteristics is its ability to create hybrid systems through the integration of its constituent technology. Then third, integration benefits. What this integration affords complementary reasoning and searching methods. Complementary reasoning as well as searching methods, and combining domain knowledge and empirical data. Domain knowledge and empirical data. Flexible computing tools. Flexible computing tools. The integration allows for the development of flexible computing tools that can solve complex problems effectively. That can solve complex problems effectively. Then you will find hybrid computing. Hybrid computing. So you'll find hybrid computing combines hard computing and soft computing, leveraging their advantages and reducing their limitations. In hybrid computing, you'll find you take the good features and remove the bad. What are the advantages of taking the advantageous parameter or the factors and removing the weaknesses and reducing their limitations? Then you'll find enhance efficiency. Enhance efficiency. You'll find this combination enhances problem solving efficiency. This combination enhances problem solving efficiency. Applications. Hybrid soft computing models are applied to a variety of problems, including classification, prediction, and control tasks. So next. So this is how the schematic diagram or a neat sketch of intersections of members of soft computing family and hybrid computing schemes. So hard computing, two circles are there. They are superimposed. That is, in between you find it is hard computing. Then here it is, in others, three triangles are there. You'll find genetic algorithm, GA fuzzy logic mixture combinations, fuzzy logic neural network, GA neural network, GA fuzzy logic neural network, fuzzy logic neural network. This is how the schemes work. So, application areas of soft computing. Application areas of soft computing. So, you will find actuarial science. That means this science applies discipline. That is your discipline otherwise. Actuarial science applies mathematical and statistical methods to evaluate risk in insurance and finance industry. For example, stocks and bonds. For example, stocks, market stocks, bonds, all those things, it is required, isn't it? So market price, depending upon, you'll find Bombay Stock Exchange value is going on or going down depending upon that. So that model can be applicable here. Actual science applies mathematical and statistical methods to evaluate risk in insurance and finance industries. Insurance means depending upon your age, what will be the policy, number of years, like that. Okay. Then second parameter can be, or second thing is interrelating subjects. Interrelating subject means it encompasses various subjects, including mathematics, or you can say finance, or you can say probability, or you can say statistics, or you can say computer programming, or you can say economics, or you can say financial economics, something like that. Say economics, financial economics. We just write like that. Economics, financial economics. Then historical approach. Traditionally, actuarial science utilized deterministic model for constructing tables and premiums. Remember, usually we use two models. Two models. One is your deterministic model, another is your stochastic model. Two models are used. Deterministic model, another your stochastic model. Deterministic means certain, guaranteed. Stochastic means probabilistic model. So from beginning we use that traditionally actuarial science utilize determine that those models which are certain. Deterministic model for constructing tables and premiums. For constructing tables and premiums. So you will find that discipline overwise. So you'll find in agriculture engineering how it is applicable in agriculture. Let us, because recently I had been to College of Agriculture Engineering for a interaction on agriculture, how scheduling is applicable in agriculture engineering. That is your OUAT, that is gift engineering, that is Gandhi Institute for 3 hours discussion. There was a topic on agriculture engineering. I have to focus my highlight on scheduling applications in agriculture engineering. So you'll find agriculture. You'll find that Jai Jawan, Jai Kishan. Agriculture is very important, vital. So how it is applicable, how we can model it. So agriculture engineering applies engineering science, because you'll find in agriculture we have some two for your kind information of the faculties, that we have thermodynamics, we have engineering drawings, farm machinery, theory of machines. Those people study this paper, agriculture. That means those who are studying at CAT, College of Agriculture Engineering and Technology. College of Agriculture Engineering and Technology. They are having some mechanical paper there. So you'll find agriculture engineering applies engineering science and technology to agricultural production and processing. So interdisciplinary nature, because of its interdisciplinary nature, it combines various disciplines, including animal biology, plant biology, mechanical engineering, civil engineering also there, electrical engineering, chemical engineering. Then you will come integration with agriculture. Integration with agriculture. It integrates engineering principles with agricultural knowledge. Some basic knowledge of agriculture is required. Then you will find biomedical applications. Biomedical applications. In biomedical, you will find design concept. In design concept. So biomedical application is a design concept in medicine and biology. In medicine and biology. Interdisciplinary field, you'll find in this field, which targets to bridge the gap between engineering and medicine. Between the engineering and medicine. Because now this interdisciplinary is being focused. People who are faculty are carrying out their interdisciplinary area, especially they are attracted or motivated to do interdisciplinary work. So you'll find this gap between engineering and medicine is being focused. So skill integration. It combines engineering design and problem solving skills with medical and biological sciences. With medical and biological sciences. Similarly, you will find healthcare advancements. The objective is to advance healthcare treatment in areas like diagnosis, or you can say monitoring, or you can say therapy, or you can say treatments, or you can say treatments. So, because we have to stick to the timings of the organizers, so will be cut short. Civil engineering you'll find, look into, because this program is also being invited by all branches, probably. So civil engineering you'll find. Civil engineering involves designing, constructing, and maintaining infrastructure like roads, bridges, canals, or you can say buildings, or you can say dams, etc. It operates at all levels from local to national governments, and from individual homeowners to international companies. Now, computer engineering. Computer engineering integrates electrical engineering and computer science to develop computer systems. So, computer engineers are trained in electronic engineering, software design, and hardware-software integrations. They work on hardware and software aspects of computing, including microprocessors, personal computers, supercomputers, and circuit design, etc. This field focuses on how computer systems work and how they fit into larger systems. Industrial machineries. Industrial machinery refers to tools comprising one or more parts that utilize energy to accomplish specific tasks. These machines are typically powered by mechanical, chemical, thermal, or electrical sources, and often include motors. This field falls within the domain of mechanical engineering. Then coming to crime forecasting, you'll find in crime forecasting, which is nothing but it is some sort of planning, is a planning tool used to manage and reduce crime in society. Crime involves breaking rules or laws, which can lead to convictions, or you can say rehabilitations, or you can say cautions, or you can say no enforcement. Using crime forecasting, you can say we can anticipate and address criminal activities more effectively. Then coming to data mining. You'll find in data mining the concept which is very often used. Nowadays it is because of interdisciplinary subject, it has been focused. So data mining is about finding patterns in big data using artificial intelligence, machine learning, statistics, and database. You'll find aims is the major aim is to extract useful information from data and make it easier to understand and use. Understand and use. And in environmental engineering, you'll find, because you'll find environmental engineering. Now, you will find in environmental engineering this. Now, you find in industry, any kind of industry, temperature should be low, That means it should be around 24 degrees Celsius, 25. And why we are studying in the environmental engineering plant, particularly this environment, because plantation, where people are going for afforestation. That is you should try to maintain that. So, environment, because you will find now global warming, it is going on. Temperature is going on. Pollution is going on. So, in any factory, safety is important. Safety, because in plant, safety is the first thing. Safety precautions, because sometimes you'll find how environment is affecting. For example, if you are working in a hazardous environment, a high temperature environment, a polluted environment, so many diseases are being happening. So many diseases. For example, if you are working in a high temperature, around 45 degrees Celsius or 40 degrees Celsius, so you'll find you are subjected to cancer, skin cancers. So you'll find some safety precautions. So environment is required. So cooling temperature is required. And for that, you'll find in industry, some incentives are given. So as a work study engineer, you must judge that. Because sometimes as a work study engineer, as a ship, you can say ship in charge, or that engineer in charge, you must look into all those things, environmental concern. So environmental engineering combines science and engineering to enhance the natural environment, focusing on air, good air, water, or focusing on water and land resources, obviously. Okay, so just don't laugh. I want to interpret here. One my friend is there working in Nalco. One of my friend is there in Nalco. He is now GA. So I am working in a government state-funded institute located at a rural place with so many constraints, so many limitations. Because I know what is the limitations. I know what is my limitations. Such environment, we do not have. Personally, I do not have AC. Personally, I do not have AC because I do not belong to a lobby group. I do not belong to a particular group category. So you will find I am working here. So without AC. When my friend, I compare that you are working and drawing so much salary, he replied me bluntly, that Dhiren, you are telling this, you come and take the fume, coal dust, then take the money. Then I understand why he is paid for a higher package, why I am paid for low. I am satisfied after looking into my friend's remarks. That is, he is working in a hazardous environment. We are not working. They are having all the facility. I am not having AC or anything. At a state-funded institute, okay, with these four conditions, I know what is the status. So when I go, because as a worker, as a faculty, I have been assigned some classes. I visit different organization. I have seen so many institutions. Last week I had been to GIFT. Previously I had been to that KIT. So many for this talk. So I have compared. So when I compare with those institutions and compare our institution, definitely, because it is state funded. People, those who are working in private college, they may feel that this is better. But when I am saying you are in better positions, because at least you have a good infrastructure. So environmental wise, you will find environmental engineering is nothing but focusing on good air, water, land resources. The objective of this is, its goal is, it includes clean air, water, and land for human and other organisms, habitation, as well as cleaning up pollution site, because this factor is to be taken care of. So taking into, because we are already in time, so running short of times, so I think I have two, three, so we'll skip it. So fault tolerance, that means fault tolerance is nothing but is a system's ability to keep functioning correctly, even if some of its parts fail. Even if some of its parts fail. Unlike systems that break down completely with even minor failures. Fault-tolerant systems degrade proportionately to the severity of the failure. This feature is crucial for systems that need to be highly available or are critical for life. Feature selections. Feature selection, also called variable selection or attribute selection, is the process in which, in machine learning and statistics, of choosing a subset of important features for building models. Unlike features extractions, which creates new features from original ones, feature selection simply picks a subset of existing features. Then, image processing. Image processing in imaging science refers to signal processing, where the input is an image, like a photo or a video frame. The output can be another image or a set of characteristics related to the image. Typically, image processing treats the image. Typically, image processing treats the image as a 2D or two-dimensional signal and applies standard signal processing methods to it. So skipping it because another 5 minutes is there. So material engineering is an interdisciplinary field applying the properties of matters to various areas of science and engineering. This scientific field investigates the relationship between the structure of materials at atomic or molecular scales and their microscopic properties. It incorporates elements of applied physics and chemistry. Mechanical engineering. Mechanical engineering is a discipline of engineering that applies the principle of physics and material science for analysis, design, manufacturing, and maintenance of mechanical systems. It is the branch of engineering that involves the production and usage of heat and mechanical power for the design, production, and operations of machines and tools. Medical diagnosis. Medical diagnosis refers both to the process of attempting to determine or identify a possible disease and to the opinion reached by this process. From the point of view of statistics, the diagnostic procedure involves classification tests. Okay. So another nanotechnology. It's about working with incredibly tiny materials, devices, and structures, usually between 1 and 100 nanometers. It combines various sciences like chemistry, biology, and physics to manipulate matter at the atomic and molecular levels, pattern recognition. This involves finding patterns in data or information to make educated guesses or decisions. It's used in psychology, computer science, and other fields to match inputs with likely outcomes, considering statistical variations. Polymer extrusion process. Polymers are compounds made of repeating units. Extrusion is a method to create objects with a specific shape by pushing, or you can say pulling, material through a mold. It's great for making complex shapes and working with brittle materials. Process control. This is about keeping a process running smoothly within desired parameters. It's used in industries like power plants, or you can say oil refinery, to automate and manage complex processes, very often from a central control room, enabling mass production. Signal processing involves analyzing or manipulating signals which can be any kind of data that varies over time or space. This includes sound, images, sensor data, and more. It's an important field in system engineering, electrical engineering, and applied mathematics, used in a wide range of applications, such as medical diagnostics or telecommunications and control systems. Smart instrumentations. As intelligent devices become ubiquitous, the challenge is to connect sensors and actuators through smart systems. A major issue is the growing number of communication protocols with no signal standards or no single standards. The challenge is to intelligently connect smart instrumentation so that devices can communicate across multiple protocols. At the same time, increases in the volume and importance of data, means that privacy, or you can say robustness of the system, or you can say security is paramount. So these are some of the aircraft and air, air traffic. So soft computing components, you'll find neural network, fuzzy logic, evolutionary computation, communication networks, fuzzy logic, neural network, EC, control and monitoring, cooling and heating, data communication, data security, induction motor drives, inverters and converters, manufacturing technology, mobile robots, multi-agent robots, network optimization, power control, radio planning, resource allocations, that is your radio planning, satellite image, scheduling, spacecraft, steel process industries, switched reluctance, motor drives, etc. etc. So, in short, as soft computing continues to advance in field like physics, chemistry, biology, or you can say material science, computer sciences need to recognize the role and prepare for its future progress. That means all interrelated scientists needs to recognize their role and prepare for its future progress. Actually, this paper has not been communicated. It is under preparation. So I thought to make it a draft in this presentation. So it is not publicized. This paper or this work has been discussed various aspects of soft computing, highlighting its successful applications and rapid growth. It's clear that soft computing will have a growing impact in the years to come. That's a call to integrate integrate soft computing techniques and tools into both everyday and advanced application. And hopefully, this overview will assist all interdisciplinary engineer as well as computer scientists or civil engineering or mechanical engineering or industrial engineering or electrical engineering or civil engineering interested in contributing to a field of soft computing. So here are some of the references which has been taken care of. So finally, we are coming to an end that anyone needs to ask, please. Hello?
Yes, audience, anybody having any questions, now you can ask.
Hello? I have tried my best because this has not been published. It is under process because the organizers, Madam Sri, Madam the Secretary of this organizing committee, they inform me that, so can you have been to KIT and other colleges, why don't you opt for a invited talk? Well, I will try to manage and do justice. So with a small gap of, this paper was my research paper of my PhD student. So it has not been published yet. So please, I have tried my level best to make it a mechanical oriented so that majority of the faculties are from mechanical background. Though it is interdisciplinary, still I have tried my level best so that mechanical concept can be understood. It is catched by all. So any questions from the audience, I'll be very happy if I can give some tips or to the best of your satisfaction. So I am highlighting all those things, what just refreshing, reviewing. So any questions from audience, if any? I'll be very happy if you put something. Anyone who is interested for PhD is welcome in interdisciplinary area, especially in industrial engineering. In any collaboration, in collaborative method, he or she is welcome. Hello. Yes, any question? Then should I go?
Thank you, sir.
Okay.
I think there is no questions from the audience. Now, if they have, they can
mail me. I have given my mail address.
Yes, sir. Yes, sir.
I have given my mail address as well as my WhatsApp number is there. So
yes,
they can contact me freely and frankly.
Yes, sir.
Okay. Thank you.
Thank you, sir.
Okay.
So your session was very informative, and we got the knowledge about soft computing and the different soft computing techniques, and the hybrid computation, about the hybrid computation, and the application of soft computing in different areas. So it was a nice informative session, and I hope all the participants must have got some information about the soft computing. So thank you very much, sir, for your informative session, and I hope all the participants will be taking the advantage of your session. Thank you, sir.
Okay, thank you.
Dear participants, we have small break for 10 minutes and shortly we start the session 3. 3:45. 3:45. Without explicit program. So with the data of our research work, we can build a predictive model so that with the unseen data also we can predict what are the results. For example, in the present data, I'm going to take the 4 input parameters, especially used in powder metallurgy to prepare some laser composite material. So I'm going to hands-on with some aluminum silicon carbide composite. So how it is going to, how building a predictive model, how the predictions will come, what are the evaluation metrics, how to measure how accurate it is. We are going to discuss on that. So before entering that, applications in manufacturing of machine learning includes predictive maintenance, quality control, supply chain optimization, demand forecasting, product customization. So generally, while dealing with machine learning models using regression, it's a data-driven decision. With our data, we are going to build some prediction model. So types of machine learning include supervised learning, unsupervised, and a combination of both semi-supervised. While going to supervised learning, in supervised learning, the algorithms learn from labeled data. Means we are going to give our data input and the output with some labeled data that here we are going to see my input parameters like variation of silicon carbide in aluminum, in the powder metallurgy compaction, how the compaction process affects the tensile strength, and how sintering temperature and time is going to affect the tensile strength. From our lab, we gathered that data of 1 year. So we have 172 data points. From those, we have labeled data of tensile strength. So that is the quality of the data. The performance of the machine learning model also depends on the quality of the data set. If any missing values are there, we can fill it up with some normalization technique. But the quality of the data will play a major role in maintaining the performance. The main aim of that machine learning is to recognize the patterns in the data, how our output is varying with inputs. If it recognizes that pattern, it can easily predict the output. So this supervised learning needs data. Example, predicting product defects based on historical data, control data. So unsupervised learning. Unsupervised learning generally used to clustering. Example, clustering similar products. These don't need any data. Suppose if you give some algorithm that clustering means grouping similar type of thing. Suppose the defected products are grouping and good products are grouping together like that. And next one is a combination of both. With some unsupervised learning, you can go for classifying manufacturing defects. So next one is the reinforcement learning. This deals with actually this learning algorithm have an agent that responds with the environment. So example in generally driving a helicopter. So while driving the helicopter, it needs, if you put in autopilot mode, it have to respond with the environment. Suppose if any turbulences come, that have to go outside of that. It have to alert the pilot. At that time, this reinforcement learning reacts with the environment. So in manufacturing, optimizing production process by maximizing yield while minimizing energy consumption. Here it is clearly showing if the product is there. That is not that much demand. Suppose ACs are there. ACs are not that much not needed in winter season. So there is no need to produce ACs in winter season. So by this reinforcement learning with the environment. So this is the winter season. So it detects the environment. So it will clearly say optimize the production process. Don't produce that much amount of ACs in this season. It will not sold out. The stock will increase. That type of decision taking will be done by reinforcement learning. So here we learn about different types of machine learning techniques. So understanding the different types of machine learning is crucial for selecting the appropriate algorithm. Here also in the present also we are going to see which algorithm, which machine learning model is best for our data and have low error. So what type of algorithm is best for our data, that we have to select depends upon the metrics and evaluation metrics of the model. So now I run all the models and which algorithm, and there's a background of the algorithm. The background of the algorithm, how it is working, how my errors are, why my errors are generating, is any algorithm is best to reduce that error, which type of algorithm will generally reduce the errors which are present in my data set, that we have to choose. So some people will do on fluid dynamics, CFD analysis data, and some people will do on manufacturing, like predicting hardness and tensile strength. So depending on that, which algorithm is better, that we have to choose the background of the algorithm. Another important thing is running the Python programming is easy. Just 2-3 lines we can write and can complete that. But how it is working, how to tune the Piper parameters, what is the background of that model, that is the important thing. We will discuss about some basics of a linear regression here before entering into hands-on. But clearly telling how the algorithms work of SVR and XGBoost, that is a different, very big talk. That is not the part of this present session. So next, machine learning process. What are the process in machine learning? So first of all, data collection. While doing experiments, we have to collect the data, whatever the parameters, wherever the category you are working in. So here in the present, I am dealing with the composite materials, powder metallurgy. So I collected the data input as silicon carbide composition, compaction pressure, and sintering temperature and sintering time. Ensure data quality, completeness, and relevance to the problem at the end. Here, data quality plays a major role. and completeness of the data. If the data is not complete and is missing values are there, generally data pre-processing is needed. What happens in data pre-processing means it will normalize the data and will fit the mean or median mode depending upon the whether it is a classification task or it is a regression task, depending upon the model. It will fill the data. So next one is data pre-processing. Already we discussed about handling missing data, outliers. Here another thing is outliers. Outliers are the points which are far away from the regular points. Actually, these outliers, what will happen means, because of these outliers, means the data points which are far from away, generally some mistake happen or maybe some defect while fabricating, the tensile strength or hardness will go away from actual thing. So these outliers causes the poor performance of the model because it will increase the error. So while dealing with this one, we will see some outliers in the data. So after running the data, if any outliers increasing the errors, we can detect those points and can retest that whether it is really at that point only or any mistake happen, so that after rectification of the outliers, we can increase the performance of the model. So transforming the data into suitable format for machine learning algorithm. This is the important thing. In the last time, what happened means generally while running the ML model, while tuning the hyperparameters. While tuning the hyperparameters, if you give more number of parameters to search in the search of the best hyperparameters, it will run thousands of iterations to find the best score, which is the best hyperparameter for this model. While doing that, it depends upon your computer capabilities. It will take time, or internet connection, it will take time in Python. So to reduce that and increase the computational efficiency, we are scaling it to small values are in a similar range, like single digits, like 1, 2, 3, like that. And also if the input parameters are in 1s, 2s, 3s, and our output is like in hundreds, thousands, like that. And at that time also there is a huge differences in that calculation, mathematical complexity. The time taken for this solving this algorithms is took like long time. So the scaling is used to transform the data by using standard scalar functions that we are going to see. Next, model selection. Already choosing the appropriate machine learning model algorithm based on problem type. So consider factor like scalability, interpretability, and performance metrics. Generally, while dealing with different machine learning models, this scalability, it is must for neural networks, because while dealing with neural networks, huge mathematical calculations lead to high time, or it will even it will show this is not possible to complete all iterations in neural networks. So, and also interpretability, sensitivity analysis, and also performance metrics. Suppose if we take artificial neural networks, to run neural networks, we need large data sets. If you have only 50-60 data points, it is waste to run the neural network because it will show some poor performance compared to others. That is based on, so depends upon our data characteristics and problem type, desired outcomes, we have to select the model selection. Next, training. That we have to split the data into training. That is the general purpose. We have to split the total, suppose 100 points, we have to split the 80 points to training. After training it, from the training, it will recognize the patterns in the data. So after recognizing the patterns in the data, how it is varying, then with our remaining 20 points, if you give 80% to training, remaining 20% to testing. So evaluation. So that 20% only we have to give input. We have to predict the output on the testing. So we already know the testing output, and it will predict the testing output. Then we have actual and predicted. So difference of this actual and prediction, we have to calculate the evaluation scores. So to increase this testing and training scores, how much is accurate, we train it, how it train it best, and how it is going to test performance on the testing. That depend upon the some techniques like cross validation or holdout validation. So from that, the difference between actual and predicted one, we can calculate that R square, mean absolute error, root mean square error. These are all the metrics to calculate the performance of the model. Next, deployment. Generally, what will happen means after prediction, after training and testing, then before deploying, we have to before deployment we have to validate that model by with unseen data with the data points which are not present in training and testing. Experimentally, we have to validate those models. So from that we can able to deploy that model. So next one, it is a machine learning process, iterative and requires continuous refinement. Refinement means we have to refine the hyperparameters so that the model will give the best outcome, which is very near to actual value. If the algorithm give result output which near to actual values, then it is a good model. So before entering into the machine learning, what are the prerequisites we need? Some basic knowledge, like Python programming we need, like, and also mathematics. So the basic like algebra, calculus, probability, and statistics. And next, data analysis and visualization. So after knowing the Python and mathematics, then in the Python programming, we have to see that how the data is varying input with how the input and output parameters are linking together. Whether it is a linear or non-linear. If it is linear, then we can run linear regression so that linear regression with simple mathematical calculations we can end the machine. We can come with the best output model by using linear regression. Next, machine learning concepts. Like already we discussed, we are going to discuss how the machine learning concepts are there, like regression, classification, clustering. So understanding how these models work in the background means mathematical calculations. How these mathematical calculations are going on in the background of the Python. That if you know, then only you can write the code for that and you can tune the parameters in the program. The next, software tools and libraries like numerical Python, TensorFlow, scikit-learn, PyTorch. These are the some software tools while we are dealing with data sciences. Next, some problem solving skills. Means if any problem came in the logic of the program, that we have to solve. So next, algorithms, already we discussed regression model. It is a data-driven model, and it deals with a numerical output, like in the present hands-on, like tensile strength, hardness. We can do regression and can predict these mechanical properties of that material through regression model. And next, classification. The classification belongs to some like classification dividing based on the hyperplane task, whether it is defect or not, like that classification. Next, clustering. Clustering means suppose in the manufacturing sector we prepared products. Some products are powder metallurgy products and some products are casted products. So clustering, grouping the powder metallurgy products into groups called clustering, and grouping the casted products into some group. That is a clustering purpose. And next one is the dimensionality reduction. This will come into act when we have to reduce the computational load. In a quick time, you can complete that thing. At that time, dimensionality reduction will be useful. Next, anomaly detection. These things generally happen if the data quality is not good, if any outliers are there, otherwise the data is not linear or non-linear, some random data don't follow any pattern, then we can go for anomaly detection. These are generally used in marketing. So by understanding all these things, how the different models are there, then we can go for which algorithm we have to implement, which type of technique we have to implement, that thing. So here, before entering into the machine learning, any machine learning technique, if you enter, generally the terminology come into act, that bias and variance. So if bias is high, the variance will be low. If low bias is there, variance will be high. See here, it is high bias linear fit. So what is the problem here means it is a generalized straight line. Linear regression means it is a general straight line. But when we have to use linear regression, if the data is linear, if the data is non-linear, if you apply non-linear regression, then automatically this line will come. So if the data is not linear, some point will be here, some point will be here. So the gap between this fit line and that point is high. That is called error. So here high bias means this line is fitted using linear regression, but it is not showing any partiality to the points. But here low bias means it is showing very low bias by satisfying each and every point. It is a polynomial fit. It is a linear fit. Straight line only y equal to mx plus c, but it is some quadratic equation or some higher degree equation with curves, so that it passed through every point, so that it is satisfied every point, so that the gap between this line and the points is 0. So that means error is 0. So the error while training is 0. So here what will happen means this is a low bias. So it passed through every point. The gap between this point and this line is 0 because the line is joining through this point. So automatically the error on the training is 0. So the remaining 20% on testing, suppose the data point is here. Here the testing data point is here. So what will happen means actually this training point is also here, this training point also here, and the testing data is also here. But if you take this high bias, this line will pass through here. So the error is 0. But due to this low bias condition, the gap between this testing point and this line is this one. Error, maximum error came because of low bias. This condition is called overfitting. Because of this overfitting of the model, because of low bias, the prediction ability on the test set is poor. So that if you give any data like unseen data or testing data, it will show high error. That is the problem with low bias. So this one generally, this is representing the linear fit with a different data point. So we will see that I want to tell. These are the linear fit, these are the training, and the gap between these are errors. We call it as error or residue. So next one is bias variance trade-off. What will happen? If already we discussed, because of low bias, the model will overfit, so that high variance will come. High variance means on the testing set, too much amount of errors will be there. That is called high variance. So here that is overfitting. This is overfitting. This is underfitting. Underfitting generally happens if you don't have sufficient data to train. So that fitting was generalized. Simple straight line will come irrespective of the data. That is called overfitting. But these underfitting can be overcome by using some higher order polynomial functions in linear regression, like poly regression. So that this, because of this curve, polynomial curve, we can fit the data with low bias and low variance, so that the training scores will be, the training errors will be low and testing errors also low, so that it is a good balance. So how to mitigate this underfitting? Underfitting causes simplified models or insufficient data, the underfitting. So how to mitigate that? So to mitigate this overfitting and underfitting, we are generally used L1 and L2 regularization technique. What is these my regularization techniques mean? Before this already we discussed the gap between the fit and the testing data points is called error or residue we discussed. Our aim is to reduce that error. So what these techniques will do means it will directly target on those residuals or errors. If the data errors are positive, it will reduce those errors in the next iteration. If it is underfitting and show some negative values, then it will add some error and it will move that residual towards the 0 point, the fit, so that overfitting or underfitting can be minimized. It will come close to that fit line, so that residuals or errors will be minimized. So this one, now I'm going to discuss about the linear regression, some basics. Actually, we are going to discuss about some 3 models like linear, because the data is not linear here. So how linear regression works? So to increase the accuracy of performance of the model, we are going for next support vector and XGBoost. How the performance will be, how the prediction will be, so that. So I am giving the basic understanding on linear regression and how it is working mathematically. Okay. So that is a y equal to mx plus c type of equation. That is a general fit here, as is shown. It is here. So everything we are doing some vector equations. Everything we are some input data will be there. That if you think that is a x1 and this is a constant and this is one y. Actually, we know this x term input and y term is output, and this one is some bias variances. Everything, if you have to give some bias. Already we discussed about low bias. So we have to give this bias condition so that it will not overfit. If the bias is 0, like we discussed, the polynomial curve will go through every point, so that high variance or high errors will come on the testing. So that's why you are giving some penalties. Otherwise, we call it as bias, like epsilon. So this is the error. So this is the error, the actual, predicted. So this is the total error we are obtaining between prediction and actual. So to minimize this total equation, we are differentiating it with respect to beta. Beta is the slope. Sir, what is that beta? What is this differentiation? Why you are giving me? This is another concept that come in principal component analysis. This is the error rate, sum of these co-erred residuals, SSR. That will come in principal component analysis, but I am giving small idea. This is the, suppose this line is there. This is the residual. Generally, this residual, so suppose it is 1, here it is 2, and it is 3. Actually, it is -3. It is +1, +2. To eliminate this sign problem, we are squaring it. Sum of the squared residuals, because here is, if you without squaring, if we add it, 2 + 1, 3. 3 and this is -3. 3 - 3, 0. So overall error is 0. So that's why to eliminate this thing, we are squaring. So after squaring, it is 4, 1, 5, square 9. 9 + 5, 14. The error is 14. So that is the sum of the squared errors. So it is the not curve, it is the collection of the points. This is 1 point, 1 point, 1 point, like that. What is this point? How the points will generate means? This is the error. Suppose for this line, number 1 line, this is the number 1 line. The sum of the squared residuals come to here. So again, if you change the line with a different slope, the errors are reduced. Suppose this is the, and again another line. So the errors are reduced. And it will, by changing the slope, the errors will, the sum of the squared residuals will reduce or increase. But we have to find this minima point. At what slope the errors are minimal. That is the principal component analysis. That's why you are differentiating this and bringing the sum of squared errors to 0. This minima point, global minima, we call it as global minima. We have to find this point and the slope at this point of this line. So that will come by this equation. If you differentiate it, means slope. The slope here, the change in slope is 0. The change in slope is straight line, means it is a 0 slope. That if you differentiate the slope to 0, then you will get the minimum point. So that is, this is the curve beta value. This beta we want. So that is beta equal to, if you bring these two equations to here, x transpose x inverse x transpose y. This is the linear regression to find the optimal slope of that line. At these, with this slope, it will give minimum error. That is the best fit. So like this, for every algorithm, different mathematical calculations are there. So for your data, what is the best mathematical model, that you have to know. When you know, if you understand the working of that model, then only you can know what is the best model, where the errors are generating in your data, and which model is best to reduce that errors. That we have to find by learning the algorithm, how the work background of the machine learning algorithm. So this is a small introduction about, we are going to discuss about SVM and XGBoost. So how that both are different each other. Modeling approach. SVM, it can handle both linear and non-linear. So it is a thing that it will separate the optimal hyperplane between two classes, or it can give prediction also. It is somewhat different. And XGBoost. XGBoost model is working on regression trees. The assemble learning method that combines multiple weak models. By taking the average of all the trees, it will give some prediction output. So majorly XGBoost will directly target the residual. If you go the background of this XGBoost, it will directly target the residuals. So that the objective of this algorithm is to reduce the error. SVM can handle nonlinear relationship using kernel tricks. What is meant by kernel means that we have to go for background of the model. And XGBoost, it uses decision trees, which can handle nonlinear relationships inherently, because there is no mathematical calculations that much. It will split the data based on features. SVM can handle high dimensional data regularization to avoid overfitting. XGBoost is also less prone to overfitting. Here, see, the XGBoost is less prone to overfitting. So it is the best. Majority of the researchers reported in various research papers that XGBoost is the best thing while predicting the mechanical properties of that some material. But random forest model is there. It is more prone to overfitting. So if any of your data is giving less scores, even though you supply huge data, it is showing very poor performance metrics, then go for random forest, because it is the ability to overfit. If the data is not fitting low, then go for random forest. It will increase the fitting of the model. And interpretability. Less interpretability due to complexity of the hyperplane and kernel transformation. But XGBoost is more interpretable. We can more interpret why the output is changing. It has some feature importance also. Why the outputs are varying. By changing which parameter, the output is varying high. Suppose in the present work, I am going to give it is giving more importance to compaction pressure. If you change a little bit in compaction pressure values, the output is vary too much. And also training speed. Generally, XGBoost is more training, more speed, handling imbalance of data. This SVM is highly sensitive, has inbuilt methods to handle imbalanced data. Overfitting, can overfit. SVM can overfit. XGBoost are less prone to overfitting. Hyperparameter tuning. See, this is the important thing while you are dealing with machine learning model, hyperparameter tuning. In the background of the model, a mathematical formula will be there. Based on that, the calculations performed. In those, these hyperparameters like C, gamma will come in SVM. In XGBoost, depth of the tree, separating that splits, all will come. What are those? We have to first study the basics of the algorithm. So next we will go into the hands-on experiment. So I will go quickly. So first of all, this is my data. Silicon carbide, silicon composition, compaction pressure, centering temperature, centering time as my input feature. And I'm going to predict tensile stress. So I'm going to first linear regression. As the data is not linear, I will show how the data is. In the first, while running the Python programming, we have to import basic libraries like pandas, numpy, sklearn. These are the inbuilt libraries. Because why Python is using in machine learning means it is object-oriented programming and have inbuilt libraries in of machine learning algorithm. So that directly you can call, and while writing 2-3 lines, you can execute that machine learning algorithms on our data set. So I have to run 3 more models. I am going as quick as possible. Understanding of the Python is important while we're dealing with machine learning models. These are the Seaborn and Matplotlib library functions to visualize the data. Already we discussed that these are the prerequisites to visualize the data from sklearn. Dot model selection, import, train test split. This command is used to divide the data for training and testing purposes, to split the data. In linear regression only, I am going to write these all libraries, and after that, I am going to simply copy paste this code. This library I am going to import from sklearn dot linear model. Import linear regression. Python is case sensitive. Even if you difference in capital and low letters also, it will show error. No, I am going to use only R square value here. Next, after importing these libraries into my after importing this, I am going to import that my data. I am going import my data as using pandas library, using pandas, which is a tool to deal with the data. Dot read my CSV file. My file name is one.csv. As it is a file name, I have to put in string. And in those, I am going to give I'm going to assign my x values as this is a two-dimensional. So it is a input parameter, silicon carbide composition, compaction pressure. These are all the 4 terms I am going to give here. Silicon carbide composition, centering temperature, and my y is in the data file only tensile strength. So assign my x and y values in the data. Now I am going to visualize the data, how the input and output, these input, all 4 input parameters, how it is varying with respect to the output. So whether data is linear or non-linear. So we can easily estimate if a linear line go on through that data, whether it will show error or not, we can visualize. I am using Seaborn library, sns.pairplot. This is called pair plot in my data. X variations. And I am going to, these are my input parameters. And y variation, that is the tensile strength. So I am going to draw the kind of scatter plot. If same data is there, histogram. So from that, I gave that what x is, what y is, what are the inputs and outputs. And again, I'm going to give some basic like what is the title, subtitle. This is called pair plot. Site layout for the diagram within the range. Then please show. So this is our data. This is the tensile strength output, and it is the input parameters. How these input parameters are linked to these tensile strength. So if you draw a straight line here, the data is not linear. Definitely errors will come here also, and here also. So the data is not linear with output. So by seeing the data only, you can know that the data is not, this model is not suitable for this, but we will see how. Then we will go for machine learning, implementing this linear machine learning with X train, X test, Y train, Y test. So we are dividing X and Y. So X is dividing into 80-20, 80 for training, 80 for testing, and Y also 80 for training and 20 for testing. So I already imported my library for training, trained, test, and split. Train, test, split function already imported. So that is x, y, and test size is I am giving 20% out of 100%. I am giving testing 20%. We can change to 30% also, but yeah, I am giving 20%, and random state is 42 to produce the same result. To means splitting and to produce reproducibility of the result. I am giving a random state as 42. So after that we split the data for training and testing purposes. No, we are going to call the function, whatever the function we imported. Model equal to linear regression, and already that model is linear regression. So I am fitting my data into that linear regression. Model dot fit. What I have to fit? I have to first train the model. So I have to give that linear regression. I have to give my X train and Y train data so that it will give and recognize the patterns in the data, how the Y is varying with respect to X. So X train and Y train. And next thing is Y predict. So after training, it have to predict on my testing data. So that I have to give only X values so that it will predict the Y value. Because later that we already know the testing Y values, actual values, but it will predict the Y test value. So that how it is deviated from the actual, then from that we will calculate the evaluation of this model. Yes, data is not linear, it will always show higher model dot predict. It have to predict by using the after training, it have to predict on X test. There is a simple linear regression. Within 1 second, the ML model is executed. We are ready with prediction. But if you want to do calculations manually, it will take nearly 1 day. Training score, I want to I am calculating the training score. Training score equal to means the actual versus actual minus the predicted value. That is a training score, R square, or mean absolute error, like R square is there. So that if R square we are taking R square into consideration, it has to close to 1. How much it close to 1? That is the best model. Like a training score equal to model dot score, the training score. The training is the differences between training between Y predicted and Y training predicted, Y test, Y training actual. So I have to give X train comma Y train. Next, testing score. Model dot score X test comma Y test. So it will calculate the score, but we have to print it. Print training score that the value is training. Already we defined that is training score. Next, print testing score testing score. So Here our model, the training score is 83% accurate. On the testing, this square indicates it can predict the unseen data 83% accurately. So that remaining 17% is error. So the data is not linear, so it will show like that only. So it is better we go for further models. So this is not that much good model, so that we can see some further models. But the time is not there. We are going now for SVM model. As already we know, in the linear regression, the model's accuracy is 83% only. So that how the other regression? We already discussed in the PPT that SVM and XGBoost can handle non-linear data. So how the accuracy will increase from 83 to how much it will go, we will see. First, we will see some SVM model. So here we will copy paste this all without typing. But we don't need this linear regression. But we will see a scalar dot. This is the library to call support vector machine, SVM. Scalar dot SVM import SVM, SVR, support vector regression. So if you run on the same data, it will take a lot of time. That is that will not compatible in the present session. So we are for applying the scaling purpose to transform the data into simpler things. We are going to import some standard scalar function from scalar dot pre-processing import standard scalar. This is the function to transform the data into simpler simpler value to perform the calculations in a quicker time. So pandas, keyboard, PLT, SVR, training and testing. Here another thing is the tuning of hyperparameters. Already I discussed about the tuning of hyperparameters. There is no hyperparameters in linear regression, but while dealing with non-linear data, hyperparameters will come because it is not a linear feed. Hyperparameters will come. So the best combination of linear parameters to find the best linear parameters, there are different techniques to find the best linear parameters, like a random search CV, grid search CV. So here I am going to use grid search. Grid search cross validation. So I am using for training and splitting the data for optimized hyperparameters, grid search, SVR, R square, and standard scalar. So next I'm going to remaining as it is in the linear regression, importing this file and assigning X and Y values. A mistake here, pre-processing. Scalar dot PROCESSING import standard scalar. See here, I already told you that Python is case sensitive. The spelling is SCALER. Next, we are going to import this file 1.csv and assigning X and Y values. Next, again, no need of this thing. Then again, we are going to split that data. We are splitting the data into X train, X test, Y train, Y test. So next, here for quick calculations and to execute or to complete the machine learning calculations in a short time, we are using scaling function by using standard scalar library. Scalar X equal to standard SCALER, standard scalar SCALER, scalar Y equal to standard SCALER. These are the two functions to scale X and Y values. Next, we are by using these functions, we are going to scale this X train first, X train scaled scalar X dot fit transform X train. Next, X test scaled scalar X dot transform X test. Next, Y also, as Y is one-dimensional data, only tensile strength. For calculation purpose, we are converting into 2D to match with that matrices style. X train scaled scalar X. Oh, it is a Y train, so scalar Y dot fit transform. We have to transform Y into two-dimensional. X train dot values dot reshape to two-dimensional -1, 1 shape dot flatten. So same like this, I'm going to transform the Y test also to scaled, Y test to Y scaled. Scalar Y dot transform Y test dot values dot reshape -1, 1 dot flatten. This is the technique to change from one-dimensional to two-dimensional before scaling. So this is the scaling. Fit that from X train is not defined. Yeah. Without execution of this X train Y test, I executed this cell so that it don't know X train Y test. So after execution, only it know the X train Y X test value. So now it knows the X train, so it executed. So after reshaping that, we can see here we can see, for example, here my X is. So these are my X values, normal 400, 350 like that, and Y 85, 95. It's a normal value. But here after scaling, we can see X train scaled value. It will convert to two-dimensional array. X strain scale into -1, 0, small values, so that the calculations will be somewhat quicker. So after scaling, directly you can implement the SVM regression. Already I imported the inbuilt parameter from sklearn.svm import SVR. So I am calling it as my simple vector machine as SVR. And now I am defining my hyperparameter. So what is meant by this hyperparameters means that we have to learn about the background of the algorithm. What is what. So kernel means it is whether 3 types of kernels will be there or 4 types will be there depending upon the algorithm. So one was linear. Linear means in SVM a linear 2 lines will come, the tube-like structure, a pipe or tube. So that that is the tube. Suppose if it's a 2-dimensional data, 2 lines will come separating these 2 data, or it will predict the 2 data. If it is more than 1-dimensional, here it is a 4-dimensional one input parameter, so that the 4 input parameters will be divided or classified based upon some pipe-like structure. So that is called hyperplane. So I am defining my hyperparameter, linear, polynomial, and RBF, radial bias. And another one is also there, sigmoid. But if you give more number of input parameters, the complexity will increase. So in the present session, the time it will take too much time to run that all the things. Is a C learning rate. Learning rate is I already discussed in principal component analysis. So the step-by-step wise movement from the top of the high residuals to it will check whether it have to come down in a single step, or if you check for big steps, it will come to down depending upon the learning rate. And next one is gamma, one of the hyperparameter to penalize or give penalty to residuals, scale and auto. So these are my hyperparameters. So I am going to, these are the hyperparameters. What combination is the best? That the grid search function I am going to use. Whether by giving this, it will learn whether linear 0.1 scale, linear 1 scale, linear 10 scale, linear 100 scale. Like all combinations, it will run. So grid search. I already imported grid search function. Grid search cross validation. So the estimator is SVM, support vector machine, and the parameters is already defined, the parameter grid, and the cross validation is 5 folds. So I am taking scoring as means it will calculate all the metrics in terms of R square. Which combination will give highest R square? It is going to give that one. Grid search dot fit extrains scale. So I am estimating the best hyperparameters with the scaled value, so that for quicker computation. So I called it grid search CV, and I gave the thing is support vector and the parameter grid I already defined, and cross validation 5. So among the scoring R2, which is R square value is the best, please give that one. With the data of X train scaled, Y train scaled. Already we saw this X train scaled. These are the data. So best parameters. Grid search dot best now print. Print the best hyperparameters obtained that is stored in best parameter. Kernel RPF. Undetermined string literal RBF. Grid search param grid is not defined. Yeah, explain scale is not defined. Now it is running that parameter that it is optimizing the hyperparameters using grid search CV. See here, a lot of things are, as the Python is case sensitive. Here I gave small one, but here I gave that the X train scale. Here I gave small, here I gave big one, capital case. So it is not matching again. So it is run that parameter. The best parameters out of this grid we got is the Erlang rate as 1, gamma, scale, kernel, RBF. So with these parameters, we have to train our model. by giving these best parameters that is stored in indenter best param. By using those parameters, that value, we have to run our model. So with this parameters, we have to run our model. Best SVM grid search dot best estimator. Best estimator. Best SVM equal to grid search dot best estimator. Next, by using this best SVM dot fit, we have to fit with X-train. X-train scaled Y-train scaled. So that is a fitting. That is we will give training by using X-train scaled and Y-train scaled value. So after training, we have to predict by using Y-train X-test. So already it know that after training, whatever the data it collect, it is trained. So the the model is after training, it will have some idea how the output is changed with respect to input parameter. So that again we have to predict the training same. Scalar Y dot inverse transform. Y train spread scaled. Yes, Y we previously converted to here. Yes, we converted the Y values into 2-dimensional. So again we have to convert it into 1-dimensional. Reshape -1, 1 dot flatten. Y test spread equal to scalar Y dot inverse transform. Y test spread scaled dot reshape -1, 1 dot flatten. Y train spread scaled. So this is the training. I am fitting my training model. Sorry. Next, I have to make predictions on this. Y train spread scaled equal to, I have to predict my training data. I already trained. Now I have to predict my Y value. Already it is trained. So it will again calculate, again predict the train and testing Y values output, because already it know how the output is changed with respect to input. So it's already know that Y train, but whatever the data it recognized, it got pattern recognition, it will again predict the Y train, but not as it is. Whatever the model it fitted, it will give that predicted scaled value, Y train scaled. So best SVM dot predict X train scale. Now I am going to Y test also. Y test predicted on scaled data. Y test predicted scaled equal to best SVM dot predict on my, no, it is on testing data scaled. So if you run, this is the fitting of the model with the best parameter. The best parameter stored in best estimator, grid search dot best estimator. So after it is, it will train, so that it will, after training, it will predict whatever it is trained, depending upon the training and recognizing the patterns of the on the training set. It is going to predict on again Y train and Y test. So that after scale, because it is a Y test predicted scale, after that it is going to transform, reverse transform, inverse transform into normal value. Yeah, that is also over. Now the machine learning model was perform its calculations. Now we have to calculate the matrix R square, how much it is on training, how much it is on testing. So same thing last, R2 train, R2 score. Already this library we imported here in the first cell. I have to calculate my R2 score on first training on data. Y train values already we know. That is the data you given 80% Y train, 80 input and 80 output. So R2 square means by depending upon the actual Y train and Y predicted, Y train predicted. So by using these two values, it will score the R square value. That is the training score. R2 test, same R2 score. So Y test already, that is the actual value is applied 20% of the data. So by training, by taking the training, it is predicted its output by using X test. By using the X test, it predicted Y test. That is Y test predicted. So depending on these values, Y test and Y test predicted, that difference between them, it will calculate the R square. So next, whatever the matrix you have to print. For printing, if we directly give R2 train, it will show, but in a good format using the float R square train. That is stored in R2 train. Dot, I want up to 3 decimals. But this time I want a test. That is stored in R2 test. Yeah. As I gave up to 3 decimals, it showed 3. Yeah. The accuracy of the model is 94% on training, and the accuracy of the model on testing is 95. As it is very close, there is no problem of overfitting, underfitting. As it is crossed 94 and nearby, it is a good fit only, 94 and 95%. Because it trained on the training data, it predicted 94% accurate. But on the testing data, it predicted up to 95% accurate. That is a nearby of 0.5%. This is not that much problem. So it is a good fit. So it's already running the model. to see that matrix, how the residuals are distributed, whether how means how why you have to check the residual distribution means, suppose in the testing data only 2 points are there in testing. One gave plus 20 error residual and another gave minus 20 distribution, far from actual value, then it is a problem. Even though the score is good, if the residuals are far from the actual one, then it is a problem. So to visualize that, we have to see how it is the residuals are distributed. Before that, we are going to see how the actual versus predicted plot, how it look like. Any far deviations are there. So I'm using plot function of figure size 8 width and 6 height, and using Seaborn library SNS dot regression plot. My X is Y test, means Y test means it is the actual value of testing, and Y is Y test predicted. So type of line, color of my line is red. So I am fixing it as red. Next, the basic thing, giving some X label. Actual tensile strength. Y label. Predicted tensile strength. I'm giving title. Actual versus predicted tensile strength. Please show so this is the actual versus predicted regression plot. This is the, if any point here, see the line exactly lies on the fitted line, so that this point residual is 0. Actual, it is on the, it is exactly matched with actual one, but these points are somewhat deviated from the actual one and showing some residual. So how much gap is there from the actual one, that we can show in that residual plot. I will complete this one because for understanding of that user scholars, it will be useful. Residuals, I am calculating the residuals, that is the difference between Y test minus predicted, actual minus predicted, Y test predicted. That is the residual. Y actual minus predicted will give residual, how much deviated from the actual. So plot figure again, fig size. I'm again taking 8,6. Plot dot, I want scatter type of plot. Y test spread. I want to draw the graph of scatter plot between my predicted and residual. So residual. Now I am drawing one line. Plot dot axis horizontal line. Horizontal line with y equal to 0. Color equal to red. line style dotted. Now another thing, I want to show some lines from each residual to the zero line. For that, I am using for loop for I, residual in enumerate, residual plot dot plot plt dot plot y test spread I, residual color equal to black and the line style dotted and the line width I want 0.5. Plot dot plot no after okay, I completed the for loop and I have to give that coming out of for loop, then I am giving same basic things X label predicted tensile strength. Plot dot y label residual. Plot dot title, I am giving it as residual plot. Please show. It's not matching. I opened this parenthesis and didn't close. Plot dot plot y test predicted I, y test predicted I. Next residual 0, color black, line style, line width. Okay. The problem is this code to draw the lines from residuals to zero line. But this is the actual plot. If see, I already showed here this line is exactly on that fitted line, so there is no error. The same line here, the line is exactly on the zero line, means it is very least deviated from this actual value. The remaining values are deviated from. So after seeing this, this is the fitted line, so this is the residual spread. So one last thing, we will conclude this with the predicted value of a known value. So as it is taking time, we can so this is the function to run that. So I am taking this input parameters of silicon carbide composition, compaction pressure, sintering temperature, and sintering time. 4, 800, 450, and 140. These are input parameters, and I am going to check how much it will give. So it is giving 248.19 megapascals as output. But if you see the real how much it is, 4, 800, 450, 140. See here, 4, 800, 450, 140. It is 255 is the actual one, but we got 248 as the predicted one. So how much error means 248.19 minus 255 by 255. It will give approximately 2.1 or 2.2% error. That is acceptable. But there is no time. But if you run XGBoost, it will fit the data much accurately and will give the scores R square values as up to 97%, 98% accurately it will predict. See, this is the XGBoost model. Here the same thing. The accuracy is 259.51. Actual one is 255. So the error is only to 1.7% like that. But so that is I am saying XGBoost performs better. So that is the applying ML model. So on this data, I run that as linear one, SVM, random forest, XGBoost, artificial neural networks, back propagation neural network. So among them, I finalized that XGBoost is the best one because of detecting the patterns in the data. So that is today's session about how to implement this thing. So by that I am concluding present session.
Yeah, thank you, sir, for your nice presentation. Any questions from the participants?
Hello.
Tell me.
Sir, good evening, sir.
Yeah, good evening.
Sir, how many data points you have taken, sir?
So exactly 172 data points we collected.
Oh, one,
So
sir.
previously we collected something 80, 90, but the accuracy is not that much good. Because it's clear the accuracy showed some 75, 78%. If the both training and testing data both showed some low scores, means it is a symptom of underfitting, because it needs some more data to train well to accurate for perfect prediction.
Okay, sir. So can you share this code, sir, if possible?
Yeah, it is already typed, I can share. But
Okay.
data availability, that with your data you can do.
Okay, sir. Okay. Just to see how to write the program and all.
Yeah, yeah.
Okay. Thank you, sir. Thank you.
Okay, any
Anyone
questions?
have any doubt?
Sir, here I have one doubt. In super vector machining, there is some
Yeah, support vector
residuals.
machine.
Yeah. There you finally there are so many residual errors.
Yeah.
But how can you ensure that this is best model for your data?
See here, we plot that linear regression model. We plotted that residual. I think no.
No, here you plotted support vector
Yeah.
machining. Can you go to that residual plot, sir?
It is visible.
Yeah.
See here, I will show. Here, it's already plotted. See here, this is the linear regression. So I called somewhere. Yeah, this is the linear regression. In this linear regression, see the residual spread, scale of the residual. Each
Sir,
residual went up to
minus
above 40.
Hmm.
Minus 42 plus 40, the residual spread is high. But see here in we run that XGB boost. Here see XGB boost, the residual spread maximum minus 20. So
And-
that errors are there, but the spread is very less. Means it is somewhat closer to the actual value.
But finally, we conclude with this residual plot, sir, whether this algorithm fit to this particular data and what are the things we need to consider.
The first one is, even though some models give, see here, this is XGB. This is XGB model. See here, the scores are 0.98. Means 98% accurate. On the testing, 95% accurate.
But in support vector, we get trained data and test data very near, sir, compared to this XGBoost.
Yeah. In XGBoost, it's trained well, but giving predictions, it have some deficiency, but overall error is low. You understand? It is robust to outliner. XGBoost is not overfitted. It is. It will not show any overfitting. Here in see here some residuals in this is a support vector. See here R test is 95%.
Yes, it
In
is
FPM.
near to trained data. No?
It is near to trained data.
Mhm.
But this R square test represents how well it is performed on testing data. Here in XGBoost, the scores 95% only, but it trained well. It recognized the pattern somewhat better, but on the testing set, it give only 95, near to 95%. Why 95% came means here the residual spread is constant. If you calculate the sum of the squares of this side and sum of the squares of this side, squares, it will give some error value, overall error, calculated error value. That is somewhat low. But see here, it is showed 95%, but residual spread is crossed 20. Here got 20. So overall score is 95% accurate. But if you estimate any of the data in this region, that falls near to 150 to 160 megapascal, the error will be high. But in XGBoost everywhere, but in XGBoost it is there is no that much far away. It's, here it is 30, some outliner will be there. And again, if you estimated this thing, it will show error up to here, near to this region. If any point is you predicted, it will show here.
But support vector only 2 points are away from the minus 20, sir. But XGBoost, no, compared to XGBoost.
Compared to SVM,
Yes, see, there are 2 points only out of the range, above 20.
Out of the 20, and also majority of the points are close to the zero line.
Support vector also same, na, sir?
No, support vector, see the upper side.
Okay.
The majority of points are away from. So these are all somewhat away from the zeroth line. If you predict any value in this region, it will go to near this point. In this region, near to this point, like that. So in the present data, XGBoost is somewhat good.
Okay, sir. Thank you, sir. Any questions from the participants?
Sir, excuse me.
Yes.
Sir, only one output, sir. Multiple outputs also can we do?
No, we can do multiple outputs. For simplicity, I showed only tensile strength. But
Okay.
if you give data, it will same procedure. It will be with hardness also, compression strength also.
Oh, we
Impact
can
also.
do it.
We can correlate with every feature. Every output feature can correlate with input feature.
Okay. Sir. Okay.
Any questions? Yes, sir, we can conclude this session. Thank you, Manohar sir. The way you presented it is very excellent, and we understand how to write the machine learning programs in Python. And this is such a wonderful experience we have how to run the program, how to test the program also. And thank you for your such a in-depth and expertise.
One thing I want to tell that machine learning is not belongs to CSE subject. CSE group. It's purely on mathematics, and it's a tool we can use in all the branches.
Yes,
So
sir.
it is a basic thing in the future that every branch, every scholar have to learn and implement in the field to predict or to increase the efficiency of the production in mechanical or in other also.
But for this, we need lot of data, na, so for conducting this much experiment.
Actually, if you don't have data, there are some other models also with the available data only by using some augmentation or with using some surrogacy models are there. So that it will generalize that pattern. These are the some very powerful algorithms to predict that outputs. So being surrogacy models and some models you can use with less data also. That papers also is there. They reported some good accuracy model.
Yes, sir. Sir, can you suggest any such data libraries which can be useful for research?
Research means whatever the data means, whatever the research you are doing, if you give these inputs. Generally, people, what you are doing, if you don't have data, generally know what your people are doing is they are transforming into the some computational techniques like molecular dynamics. So by using without any experimentation, they are coming out with the data by using some molecular dynamic simulation.
Yes,
So they are giving that data to the machine learning model, and without any experimentation, they are deploying the models in the industry.
okay, okay.
And another advanced technique is nowadays coming image processing.
Very deep
Whether
learning.
by using different types of their image segmentation, different types of their classification, clustering, like DB scan, bridge algorithm, so many are there. So after this, in our mechanical, another thing is image processing. Means we can detect any pore values, grain size.
Okay.
By giving just a model image, it can calculate the porosity and grain size.
Okay, sir. Yes, sir. Thank you for your nice presentation. Thank you so much, sir.
Okay.
Can you share that code? Maybe I can share to our participants. It may be
I
useful
will
for.
share this SPM and linear regression.
Okay.
And XGP. So with you.
Yes, sir. You share me. I will share it to participants.
Okay, I will mail to you. Then I will.
Okay, sir.
Sure. Okay, I'm leaving. Thanks to
yes.
one and all.
Thank you, sir.
Okay.